Okay, so the next portion of this is really talking about that developing logic and starting to think computationally. Um, and this is the point where, we would sit down and start to sketch out the thing that we're trying to create, the object we're trying to create, thinking about the geometric problem that we're trying to solve. And in fact, Guillaume and I have sat many times in the office, like sketching out, or what if you did it this way, and what if you did it that way? Because it's important to think computationally, and each person thinks in their own unique way. Like me and Guillaume, we could probably solve the same problem, but we come at it at maybe two different ways. So every time you start a problem in a script, we start with a little sketch or a little brainstorm. In fact, the one thing I miss, which we don't have in the office, is some good whiteboards. Like to think through problems with a whiteboard is a great way to kind of start your script. So if I was to say to you guys, how would you think through the logic of a simple box? What is the logic behind a box? How would you define a box? Let's say I'm on Earth and Guillaume is on the moon, and he needs a cube to fit into. I'm literally making the story up as I go here, but he needs this special cube to fix his spaceship. And he can only talk to us by um, audio or something like that. How would he describe what a box is? If you want to shoot your questions in Discord or in the comments, shoot them now. But it's as simple as you might be thinking, right? A box is defined through three things, and four if you're talking within the context of a 3D environment. You can define a box through an origin, a length, a width, and a height, right? Through those three parameters, and four because we're talking about the context of it being in Rhino, and it's floating in space somewhere, right? So we need to tell it where. Through those parameters, I could tell Guillaume what size he needs to make, or he could tell me what size. I don't even know who's making the box at this point. I could send him the dimensions of the box that he needs to make, or something like that, right? So I want to start off by thinking, how do we actually build a box in Rhino, just to show the difference in mentality of modeling in Rhino versus Grasshopper. So I'm going to jump into Rhino. I just opened up Premiere. That's annoying when you accidentally click things like that. I'm going to get rid of all my little sketches and stuff. So how do I actually make a box in Rhino, right? I simply type in, for those of you who are kind of new to Grasshopper, I can type in the command box, or if you just simply go to the little icon here, let me turn off After Effects if I accidentally turned on, because it takes up a ton of memory. So yeah, we'd hit box, this little icon here. And for those of you familiar with Grasshopper, you know that familiar with Rhino, you know that it's 1, 2, 3 clicks. I've made my box in maybe less than a second, right? But if we just pause a second and think about what we're actually doing in Rhino, if I go back and repeat that command, the first click is the origin. The second click, I am at the same time defining the length and the width of my box. And the third click is defining the height, right? Of course, I can also click and input the number 10, 10, and 10 in order to make a more defined size box, right? So that's how we make a box in Rhino, right? So now let's look at how do we actually make a box in Grasshopper. And some of you may be shouting out, I know exactly how to make a box in Rhino in Grasshopper. So the first thing I'm going to need is what component am I going to use to create my box? So the first thing I'm going to do is double click on the canvas and type in box, right? And you can see there's a bunch of different there's boxes. There's a 2-point box, there's a domain box, there's a center box, evaluation of box properties. I'm going to tell you which one we're going to use. We're going to use a domain box because it's kind of got a pretty similar setup to what we're aiming to do. So if I click domain box, I think that's going to be the right one. You can see, let's have a look at the component and see what is it we're actually looking at. So here's my component. This creates a box defined by base plane and size domains. So it's asking for a base and then an x direction, an x dimension, a y dimension, and a z dimension, right? So as I look in Rhino at the same time, you can see it's already got like a box that's it's started to create for me. So the base itself, by default, the base will be the XY. For this instant, I'm going to leave that as it is. But as you saw with the sphere, we could input a point, and that would represent the middle of our box, the bottom of our box. The X, Y, and Z, they are obviously linked to our length, our width, and our height, right? So instead of the words length, width, height, we're talking about the vectors X, Y, and Z, right? X, Y, and Z. So these are going to be the dimensions of my box, right? So all I'm going to do is simply add a number slider. So if I type in slider, you'll see here, I can just add that into my X. I'm going to copy that, add that into my Y, and again, add that into my Z. And you see, I now have my box that's shaped the same. And then this is the point where I can actually play with these sliders and actually change the size of my box. Now, at this point, you're probably thinking. Actually, before I get to that, I'm gonna tell you guys how to actually control your sliders. So by default, a number slider goes from 0 to 1, right? I'm working in meters, so that's not too bad. I'm going from 0 to 1 meter. But, I might want to make a box that's like 10 meters big or something like that. In order to do that, you can do it two ways. You can right-click on your slider, and under Edit, you can choose the minimum and maximum size. So the maximum is 10, and the minimum is 0. You can change whether it's like 1 digit, 2 digits, 3 digits, and various other settings, right? This is how I started off using sliders, and it's kind of useful, but it's kind of painful. I have to do this for each time I use it. Instead of doing that, what I can simply do is double click on the canvas and type in a number. I'm just going to hit 5, and it automatically creates a slider. So I'm going to click OK. I kind of know that my box I want it to be around between 0 and 5 meters. If I put in 5, you'll notice the slider goes from 0 to 10. So it gives you a little bit either side, right? So now I can copy this, and I've now got like a bit more control over my box, right, compared to the ones I made. At this point, you're probably thinking, this Grasshopper stuff is a complete waste of time. Like, it's taken me a millisecond to build a box in Rhino, and it's taken me like a few minutes to build this box in Grasshopper, right? And you're not wrong, right? It's like, obviously, if we are comparing to make a box in Rhino and Grasshopper, it's two very different things. Also, please do follow along, because we are going to use the box in a bit to do something a bit more interesting. But here's my box, and here's the pros and cons. Obviously, this is an incredibly simple. Like, we understand that you guys can make a box pretty easily, whether it's in Rhino and probably Grasshopper. But this is a really dumb example to show you the benefits of Rhino versus manual versus computational modeling, right? Yes, it didn't take me long to make my manual box. But what's great about this is now I can kind of play with my design in quite an interesting way and iterate through different size boxes. So even though it took me longer to make this box, I'm getting more use out of it because I can explore more iterations quicker, right? Now, obviously, I can do this in Rhino. I could type in the command scale 1D and sort of do, the, oh, sorry. sort of do something like this, right? And then do something like this. It's a little bit clunky, right? It's not quite as good. So that's what this is a very dumb example of yes, some things take longer to do in Grasshopper if you're comparing it apples to apples, but I get a lot more from it by doing it computationally, right? So even sometimes I'm at a point now where even for myself, I can I can model stuff very quickly in Grasshopper, even if it takes me the same amount of time to model it in Rhino as it does in Grasshopper. I usually do it in Grasshopper because afterwards I can do and flex it and explore a lot more things, which manually in Rhino is just a little more clunky. So that's a very, very simple example of, thinking through a very dumb problem and the pros and cons of modeling it computationally versus Grasshopper. Um, so this kind of brings us to our next point. So how do we define a box? We've kind of done that, right? This brings us to a challenge, and this is where Guillaume will take us through the next part of this course. Uh, so, Guillaume, we'll come on to stage and discuss how we'll actually do this a little bit. So the challenge that we're going to go through is we've made a box. It's pretty easy. You're probably not super excited at this point about spending your Saturday afternoon making a box. What we're going to do is look at a much more kind of obvious computational use of, instead of just creating one box, how would we create a series of boxes that are being affected by something? So each box is varying in height, right? So this is the challenge that we're going to try and do. And we're going to talk through how we would do it. So this is the challenge we'll try and do. Like I said, me and Guillaume might look at this and do this in two different ways, and that's fine as long as we end up at kind of um, similar results and we have similar control over the scripts. Like we're able to change the size of the box and heights. So this is usually where we ask you guys, yeah, there's someone that's saying point attractor. Yeah, use an attractor. Yes, you're absolutely correct. So yeah, there's one way I could do it. So from this image, I want you guys to think in your head, how would you actually make this? What are the steps? Some of you are already going to like point attractor, which is great, but start to think initially, what are the kind of things to do? I'm going to start off by saying one way that I would do it is I would take a box and array that box in 20 by 20, and then I would use a point attractor in the middle, like you guys are saying, um, to change the heights of the boxes. So there'd be a point in the middle, let's say. The closer the box is to the point, the smaller the height of the box gets. There's a little bit more nuance in this image, point attractor versus not point attractor wise. Guillaume, how would you think of doing it?
So I have two, but I'll start with a weird one I was thinking of this morning. Um, what if there was an image on the ground, like a grayscale image, and then
Yeah.
the darker the pixel the box is next to, the taller it would be?
Yeah. That's
That could be
another
a
way
cool one.
that would be totally valid. You could even kind of control that image computationally as well. Um,
But maybe let's see if we have other ideas. Surface to control the height, yes. Pull cap up. Um,
bulky.
that's actually what we're gonna do this time. So the point attractor, the thing is that if you just have the relationship of the height of the box to the distance of the point, it's kind of gonna be a straight kind of uh, cone almost from the
Yeah.
point out. You don't have so much control. You can have more control, and there are ways to do it. But in essence, you kind of have this very strict relationship. With a surface, you can kind of do what Ollie was showing earlier with the curve, kind of play with it, and then your boxes are going to adapt to it uh,
Yeah.
live.
So Yeah, I think there's a few good ones in the audience. Like there's different ways to do this. The way that we're going to do this, we'll go through the steps and we'll prescribe how this one is going to be done. But obviously, it's great that you guys think of different ways of doing it. The reason why we're going to go with a surface that we're going to use to project some points onto and create our heights of the boxes, right? The reason why we decided to show you guys this is because we're going to do a kind of a point attractor with the tower-ish, although it won't have a point actually, but it kind of covers the basics of a point attractor. But in this, I think when you're first getting into Grasshopper, it's nice to have a balance between being in Rhino and using computation, right? So in this example, you can manually control the surface. So again, as a designer, you have that nice flow of touching and creating the surface. Whereas computationally, you need a slightly bit more computational knowledge to make it look really good. So we're going to start off by first creating a grid. That's going to be step one. We'll then create a surface manually in Rhino. We'll then create a box at each one of the intersections of the grid. And then we're going to project the points onto the surface to get the heights of the boxes. And then at the end of it, we should have a kind of a little box sculpture. Which is it's not based on a project or anything. I guess it's similar to if you've ever been to Berlin, there's a sculpture very very much like this. So yeah, let's give that a go. I think this is where Guillaume, you're gonna talk us through how to do this, right?
I'll take it over.
There you go.
So here's my screen, and I use the same box component that Oliver was showing earlier, the one where you set the 3 coordinates and the base of the box, which was another question actually in the chat. What does the base point represent? It's if you plug in numbers here, it's actually going to be the corner of the box. So if I do 5, I'll set a box that's square to start. You can see that the base here is actually the origin of Rhino, and it starts from here. There is a little subtle thing here is that it's actually, if you look at the input, it's asking for a domain and not a number. So when I put a number into a domain, it automatically understood, okay, I want the box to be from 0 to 5. So from 0 to 5 here. But what you could do is set a domain, and I'm not going to go too far into it. Say the domain is from -5. So I'm going to use the negative here to have the negative of 5 here. So that's the start of my domain, -5 to 5. And replace, instead of plugging the 5 here, I plug the -5 to 5 domain on both of these. You can see that now my base point is still here, but now it's at the center because I'm going in both directions using the domain. We'll skip that. We'll just use the corners for now for simplicity, but just know that that's how you can control things. All right, so I kind of like sometime working backwards when I look at a problem like this. So I know I want to build boxes. What I miss here, if I set my box to be just a 5 by 5 square, what I miss here is where to place this box in space. And Ollie talked about a grid, so that's going to be how we're going to actually place all these boxes. And then the last piece I don't know is the height of the box, which relates to our surface that we're going to build. So the first thing I'll do is place all these boxes in space, not worrying too much about the height yet. So for that, I need some base planes, or actually points. It's kind of the same thing. A point is kind of a simpler version of a plane, and Grasshopper understands that if I plug a point, I actually meant the plane that's at the location of that point. So I will create a grid. So if you double click and search for grid, unfortunately, you won't find anything. And that's sometimes the limits of this search tool. You kind of need to explore and find stuff. And that's how you kind of discover new things once in a while. But the actual tool is called rectangular grid. And that's a weird one because it actually doesn't even say rectangular grid. It just says rectangular. So that's the kind of thing, you know, you need to dig in a little bit and find, unfortunately, or just ask for people that have done that in the past and what they used. All right, so the first kind of reflex when I start and use a new plugin or a new component is to look and fly over the inputs to make sure I understand what I need and what it's doing. So if I fly over here, it needs a base plane for the grid. So that's actually gonna be the start of my grid. Then I need a size of grid cell in base plane X direction. So that's the size of my grid in the X direction, which is represented in red in Rhino. Same thing in the Y direction. So a dimension for the grid in this dimension, in this direction. And then an extent X and Y. So this is gonna be the amount of points I'm gonna place or I'm gonna create from the grid in both directions. So let's get started. How big do we do it? Let's do a 20 by 20 grid. So we have 400 points total. So that's gonna be my extent. I want 20 boxes this way, 20 boxes this way. And then the other input I can set already is the size of my grid. So let's say I want to work with my boxes being 5. I want something a bit bigger. Let's call it 7 for now. And I'll plug this in both directions. So now I have a square grid. Each cell is 7 in both directions, and there is 20 of them in both directions. And by the way, there was a question about units. You actually don't manipulate any unit in Grasshopper. See, I place 7, and I don't really know what 7 represents. It's just 7 units. But what it is 7 meters, because in that case, my Rhino file is set up with the unit in meters that you can see in little. If you want to change that in Rhino, go to units, and then you can change it here. But whatever I do, if I change this now to millimeters, what I reference here as 7 would suddenly be 7 millimeters in my model. So keep that in mind. Okay, and then I'm happy with my plane starting at, or my grid, sorry, starting at the origin of my world coordinate system. That's fine. And so let's look at the outputs now. We have cells, which are grid cell outlines. This is actually what I'm seeing here. There are little squares. And the other input or point at grid corners. And this is great because for my box, I can actually input a point here. If I was to input a cell, well, that doesn't seem to work quite well because I'm putting a curve into something that's more defined by a point. So it's not quite working. I'm actually surprised it's not telling me that there is an error. But the point itself, you can see as I'm putting a list of points, and we'll go through the list after, I'm putting a series of points into the box component. It's creating a box at every single point that the grid generated. And that was also a question earlier about the sphere. How do I do multiple spheres at different point location? Well, you simply have to input in the center or the point, the reference of your sphere, just input a lot of points in there and you'll create a sphere for each point. All right, so we have kind of the basis now. We just want to manipulate the height of these boxes, which right now is pretty small. By default, it's set to 0.25. So what I'll do is I'll do the manual way of creating the surface. So I'm just going to create a surface slightly bigger than my grid here to make sure I cover it all. And then if you're not familiar with this command, I do rebuild in order to give myself a little bit control points on the surface to make a nicer landscape. So I have this little toolbox coming, maybe 6 by 6 point is fine. If you're not familiar with rebuild surface, there's probably a lot of videos about that online. But you're basically reassigning the amount of control points that are used in order to generate that surface. You can kind of see here now I have more grids visible. And if I turn my control points on by pressing F10, like this, you can see that I have access to a lot of control points here on my surface. Whereas at the start, I just made the 4 corners were the only points I could control. And I'll play with it a little bit. Maybe I'll leave this corner up here. Maybe I'll move this up here a little bit. Maybe I'll move this down. All right, so I have kind of a fun landscape. And this is this thing that you'll keep manipulating until you're happy with your design. Right, and I'll move this all up a little bit so that I'm sure that I don't have boxes that have kind of a negative height. I just want this to be kind of the top of the curves of the boxes. All right, so now this surface is in Rhino, but I actually don't have it in my canvas yet. So I'll do the little trick that Holly showed earlier, creating a surface, but creating the surface tool with the little black hexagon, which is kind of just a container to reference things from Grasshopper. If you want to find it in the menu, it's these guys. At the first tab and the first kind of panel, these are all your containers, whether they're surfaces, etc. And then I right click on it. I set one surface that brings me to Rhino, where I can select my surface. You can see it turn in this red shade, meaning that it's been referenced in Rhino. And I can even hide my surface now in Rhino so that I can see through. And you can still see the reference that actually exists within Grasshopper that I select here. All right, so now the question is, how do we use this surface in order to define the height of these boxes? Well, what we're going to do is basically these points that we use to create the box, we'll just project them up onto the surface. So I'll do that right now. So in order to project a point, the first reflect would just be to search for project. And you can see there is one tool called project point. That sounds like it's a good tool to use. I check again my inputs. It's asking me for the point to project, a direction. So in that case, the direction is going to be straight up because I want to project my point straight up to the surface. And then a geometry to project onto, which is the surface I just defined. So I'll plug this here. In order to set the direction, it's asking for a vector. You can kind of see this little white arrow in the black box. So I could go into the vector here and then vector, and then I can see there is a lot of ways to create a vector. In that case, I just simply want to go vertical, and some useful ones are these 3, unit X, Y, and Z. These are simple vectors, 1, 0, 0, 0, 1, 0, and 0, 0, 1, which are basically describing the direction of X here, horizontal going to the right, Y horizontal going to the back, and Z is vertical. So I'll use this one. This is simply creating a little vector that's in the Z direction. You can see its coordinate is 0, 0, 1 going up. I'll plug this in my direction. And now the last thing I need are my points I want to project, which are the points I used to create my boxes here. So I can simply plug this in there. And now you can see the result of the projection. So every single point has now a new point that comes out from this component that's located on the surface. Okay, now we have points, but what we really want in order to create our box is a height, so an actual distance. Right now I just have points, so I can't really plug this in because it wouldn't make too much sense. What I want is the vertical distance between the ground and this point that I projected, or that is on the surface. So distance, pretty straightforward. I'm going to look for the tool distance. Again, I look at my input, first point, second point. This one is as simple as it gets. Just want to measure the distance between my points that are on the ground, so these guys, to the points that are lifted up on my surface, which are this outputs here, projected points. All right. And now I have a whole list of numbers I can use, which are the list of every single height or every single distance from the point on the ground to the point on the surface that I can now use to create my box. And that looks like we're pretty close to the final result. I'll do a few things. I will hide what I don't want to see. So I right click and press preview here to hide the grid on the ground. I can also hide these points here. So I can do this, or I can do Control Q in order to quickly hide this component. Distance actually doesn't show anything on my canvas because we have just numbers here, so it's not represented in Rhino. And then what I'll do is I hide the surface here as well, so we can only see the boxes by themselves. Okay. And Grasshopper by default is this kind of transparent red, which makes design sometimes a little bit hard to evaluate. So what we'll do is create a kind of a custom preview using custom preview, the custom preview tool here. And this is simply to render a geometry that you plug into G and using a material. In that case, the default is this bubblegum pink color, but you can change it. And I typically use the swatch. Is the simplest component in order to pick a color swatch here. By default, it's white, but if you click in this box, you can set whatever color you want. Maybe we'll do a gray. And there we go. Now we can see this a little bit better. What I like to do also is, thanks from Grasshopper 6 version and on, we have the Arctic mode, which is kind of a beautiful way of looking and starting to have a little bit of shading in your model. You can see that it brought up the kind of red shade, which comes from this component, so I'm going to hide it too. And now I can see my beautiful sculpture here. I'll bring back my surface that I had hidden in the previous steps. And I will make it, I will set it into wireframe mode so we can kind of see it as a transparent. So I said object display mode, wireframe. All right. And now I can go back, show the control points again, and start playing with maybe this location. I want it a bit lower. And you can see that it lives it up. It recalculates all the distance. It projects back all the points on this new surface each time I change it. It recalculates all the heights of each box and regenerates all the boxes. So you can see that with my little computer, it's almost live here. So it does things pretty efficiently. All right, should we start taking questions from the audience?
Yeah, I think if anyone has any questions for this guy, let's come back on Guillaume on screen.
Or Oliver, did you want to add something that I missed?
No, I think that covers it. I mean, again, I think this is a great example of like now you can change the size of the boxes as well. After you've played around with it, you can, once you've completed it, you can flex with it. I think this is one of the most underrated advantages of Grasshopper and computational design, and is like a great example of why I think even if you kind of know what the design might end up being like, why we would use it.
I'm going to show the script a little bit bigger so everyone can see all the steps here if they want to redo it at home.
So what I did, I've copied the script as well, and so what we'll do is we'll load this onto the Google Drive. So during the break, you can take a look at it in case you fell behind on a certain part or missed something, the script is there. I know we've had a few people saying that the quality is a little bit low. This is our first time streaming, so apologies. Can you make the stream 1080p next time? It's really hard to see details. Yeah, I think we'll work on that. This is as good as we can get right now. I think if you take it to 720, it's not too bad. How do you find the different grays? Yeah, I guess we won't answer that because it's going to get a little more complicated. But for example, you can create in Grasshopper. It does have a little picture input that you can choose. If you have the domain option for creating boxes, do you also have to use domain for the grid parameters?
So the parameters of the grid itself, if you look at it, they are just numbers. So sorry again,
Yeah.
it's pretty small. But what's in the little hexagon
Okay.
is a 0 and a 1.
If you zoom in a bit, I think you'll be able to get it a bit. Yeah, there you go.
Yeah.
But still,
Well,
the little box is a bit
the
small.
little box app doesn't zoom. But it's basically, if you go in parameters, primitive, you can see that the number is this little 0 and 1. If you have it open on a computer, that's the same input. And it's just a number. So a domain is two numbers, kind of like bookending a series of like an infinite series of numbers, basically, just what a domain is. But a grid in that case doesn't need a domain because what it's asking for are simply the size. So that's just one number of the grid itself, and the amount of points you want on that grid to be generated. If that's
So
clear.
guys, I'm loading the box sculpture script and a Rhino file into the Google Drive. If you look in the comments below, you'll be able to open it and try it yourself. It won't look exactly like Guillaume's. I decided just to rebuild it on the side, but it's the exact same script. The surface is also there on its own layer, so you'll be able to kind of play with the surface as well.
So the question is, for this method, you had to create a surface for editing in Rhino first. Is that the best way to do it? Any reason why the surface was not created in Grasshopper? Well, we touched on that a little bit. It's really a choice. Like, you can definitely define your surface in Grasshopper, but to do that, you'll need other inputs. Like, how do you define where it is? It's probably going to be a bunch of points that are going to be the control points of your surface, for example. What do you do? Do you do these points in Rhino and then create the surface in Grasshopper from this point? Or do you generate even these points in Grasshopper and suddenly you have, in this case, I have 36 points. Each of them has 3 coordinates, X, Y, and Z. So I'd need all these parameters to define my one surface. It may become really complicated to manage and know, like, manipulate the surface. So in that case, it's a little bit better to have it visually in Rhino, kind of manipulate visually, because I'm guessing in that case you're trying to design this sculpture, and then import it into Grasshopper as a reference.
Yeah, I think, Daniel, the other reason why we decided to show you guys this version is, like I said before, was in this way, we're assuming there's a basic knowledge of Rhino. So as Rhino users, you probably are more competent creating a surface than in Grasshopper. So what's nice about this, and honestly, even in the office, we often lean towards stuff like this because it allows the designers themselves to have that kind of control. You'll see in the second part of this course of today, we're going to make a tower, and we're going to make them out of 2 different ways, one completely computational and one out of a manual mass, to illustrate why we would use a kind of hybrid approach versus a pure computation approach. So I know there's a few questions of like, this is a hybrid approach versus parametric. You're absolutely correct, but sometimes it's a better option for the design. So yeah, that's a good question.
I have to create the grid, then you need to bake the box. Yes, I didn't actually do that step, but if you right click here, like right now, all this geometry, I can't access it in Rhino. I just have the surface. So if I go in my box here and bake it, and then I'll put it in the default layer, I can turn off Grasshopper, and now my boxes are here. And their actual geometry I can start manipulate if I want it in Rhino.
This is a good one. Are there standard practices for the organization of components in Grasshopper? Well, Ben, you've tempted me here because this is like maybe I'll show my screen, Guillaume, just to illustrate this. Oh,
Yeah, go
I
ahead.
mean,
I
Guillaume,
can I can kind of tidy it.
yeah.
I think that's
So
something we'll cover to a little bit more in 102. But
yeah,
one thing I have actually not done, but one good thing is to try to use the grid that's kind of faint in the
yeah.
background. It helps organize things in columns, in lines. I tend to keep my cable as straight as possible unless I need to have it kink.
In fact, Ben, you've inspired me to maybe do a YouTube video on how to do this because
Grasshopper management.
yeah, this is something that's when you're working on massive scripts, you do need to organize it in a certain way, and Elephant has a nice way to do that, which maybe I'll do a video. But yeah, Guillaume's explaining it well. Like the grid is there, and it can be used, so you can see like aligning components and just giving yourself a bit of space, so it's not. Like we try and avoid the spaghetti craziness, man.
Yeah,
It's almost become like a badge of honor in the Grasshopper world for your canvas to look like this insane spaghetti mess. But yeah, we try and avoid that. So yeah, there you go.
that's no good.
But you know, sometimes scripts they do start like that. But yeah,
Yeah.
it's nice to clean it up a little bit. But yeah, maybe we'll do a little YouTube video on that.
There is no standard. One other thing I like to do is create little intermediate container. So these don't do anything, but it's kind of a stopping point of like, okay, I created all my boxes. I put them here. I highlight them by doing a little group around.
Yeah.
And again, we'll touch on that in Grasshopper 102. And you can even rename that and say, these are my sculpture boxes.
Yeah. So, guys, just because I'm thinking we'll answer a few more questions. Guillaume, I think maybe we'll take a break after this before we go into lists because we just gone over the 2 hour mark. We're just over halfway, guys. We're going to talk about lists after this and then script and actual building. But I mean these questions are great. Honestly, we didn't expect so many people to be interacting with the questions, so this is awesome. Marcus has a question about it might be too complex, but how would you define, if these things were pillars, for example, integers in its height? This is like it is a little bit complicated, but I could give you guys a bit of a clue. There is a component called round2, I think it is.
Just
Guillaume,
rounds.
is a round? Do you have a round? I'm just seeing if it's a normal Grasshopper component or a.
It is. Yeah. It's in math.
Yeah, so there's one to round to nearest.
Yeah, you have nearest, floor, or ceiling here. So nearest being if you have 5.6, it rounds up.
Yeah,
If you have 5.4, rounds down. Floor rounds down, ceiling rounds up.
yeah. So that would at least round it to an integer. There's another component I was thinking about called round to nearest, which is part of pufferfish. Super useful. And what you can do is you can input a bunch of numbers that are round to, and then you input the numbers it should round to. So like let's say each one of these boxes is in 5 meter increments, you would add a list of 5, 10, 15, 20, blah, 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 and it would find the nearest one to it.
That's
So
cool.
yeah, that would kind of be the next step of optimizing this structure based on some construction, parameters or something. Why won't the boxes go down when I move the point of the surface negative below the base plane? That's a good question, actually. And that was one we should have added, that like your surface needs to be above the 0. And that's because the project component, well, first of all, our grid starts at the 0, and we're telling the component to project the points in the Z only upwards. So if your surface is below our grid, the point is just going to shoot off into space, which results in no box because it has zero height, right? So it's a negative. Someone also asked in the question about like if you wanted to make it like Manhattan and create like a Central Park in the middle, that would be really simple. You just cut a hole in the surface, and then there would be no points the points would hit nothing. Therefore, you'd create like a Manhattan Central Park. There you go. So Guillaume's just on it. Georgie's coming in with awesome work. Now that we have everything set up, would it be easy to move everything away from the origin? Yes and no. I guess the most simple way, yeah, as Guillaume's already on it, like the grids component did have an input for its location. So we could do what we did before and create a point. That's going to be where the grid will go. But of course, we need to make sure that our surface moves as well with it. Because our surface is manual, we have to kind of move it around. But now Guillaume could select the point and the surface and move it anywhere, and it would work. So if you didn't want to start off in the origin, you could be really smart and use the corner point of the surface as the origin, but then it becomes a bit of a loop. But so yeah, Georgie, there you go. You can move it around anywhere you like. Yeah, I mean, some other people are coming up with some good things. There's one here. In order to have the more control of the boxes, you could also remap the distances and set minimum and maximum heights. Exactly. That's another way you could totally do this. We will be doing remapping in a minute when we do the towers, so I won't show you. We won't show you guys how to do it, but yeah, that's a great point. How about making the same using an actual site instead of a grid? Yeah, I guess you could. I don't think we'll have time to show you guys that, but you can see you're pretty close. So instead of the box and starting with the grid, you would start with I guess you got a CAD of all the buildings and plots and sites, and you would find the center point of each one of those curves, project that onto your surface, and extrude that based on the height. So everything would pretty much be the same, but you'd replace the grid with your grid of an actual site, and you'd have to find the center point of those curves, which you can use the area component to do that.
Anything is possible. You just need to find, what steps you're gonna use in order to get there.
Geordie's coming in with it's a great question. Someone asked me this when I was teaching it last time. So we're going to answer this a little bit later, but this is a great question. So why are some wires dashed and others are like solid, basically? So maybe I will very, very quickly explain this, but we will explain this a little bit later. So yeah, Guillaume's already on the case. So there's basically three types of lines in Grasshopper. There's a solid singular line, which you can see there. Guillaume has, looking into the panel. A solid single line means there's one piece of information inside it. And we're already dipping into the next part of this, but there's a single piece of information in it. The second wire that Guillaume's getting is solid, but it's doubled up. There's two solid lines, or there's like there's two ways of describing it. I call it a double solid line. And that means it is a single list with multiple items in. So just to repeat, a single solid line is a list that has one piece of information in it. A double solid line is a single list with multiple pieces of information inside it. And then thirdly, the dashed line means that there is multiple lists with multiple information in each list. So you'll see there's a little break where Guillaume's mouse is. He'll zoom in back in a minute. So that's a list inside of a list, which is called a data tree. So Georgie, you've tempted us into the to the next site. You're already ahead of the game, man. But yeah, so that's all I'm going to say is a single line is a single item. A double line is a single list with multiple items in it. And a dash line is multiple lists with multiple items inside of it. And that is called lists and data trees. And maybe that's where we'll stop for questions. And we'll take you... and we'll take, maybe at this point, we'll take a 5 minute or a 5 to 10 minute break. What are we on now? It's basically 5:30 here in the UK. It's 5:27. Maybe if we break for 10 minutes to you guys get yourself a coffee. I'll make a cup of tea here in England. Guillaume, you'll have a cold brew coffee in America and maybe a croissant. And we'll come back on so you guys can catch up. So if you want to download the current script or my version of it, which is exactly the same as Guillaume's, it will just, the surface is slightly different. You can go to the Google Drive in the comments and download it and give it a go yourself. Otherwise, we'll be back in exactly 12 minutes at 40, wherever you are in the world, 22 or 40 minutes past, depending on how you look at it. We'll jump back on. So yeah, we'll see you in 12 minutes. Cool. I'll
enjoy your coffee.
Yeah, grab a coffee, and then we'll jump back on to do lists. And I'll just give you a little bit of a preview. I'll give you a little bit of tips. We'll be doing lists, and later on we will be learning how to script the Biggs Cocoa Towers in Miami.